Section 23 of Sun, Moon and Stars. Astronomy for Beginners. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Prajakta. Sun, Moon and Stars. Astronomy for Beginners by Agnes Giberne. Chapter 2. Some Particular Suns. The glory of the Lord shall endure forever. The Lord shall rejoice in his works. PSA 104:31. In the constellation of the Swan, there is a little dim sixth magnitude star scarcely to be seen without a telescope. This star, 61 Cygni by name, is the first whose distance from us it was found possible to determine. We may think it strange that so faint a star was even attempted. Would not astronomers have naturally supposed it to be one of the farther distant stars? No, they did not. For though 61 Cygni showed but a dim light, yet his motion, not the daily apparent motion, but the real motion as seen from Earth, was found to be so much more rapid than the motion of most other stars that they are rightly guessed 61 Cygni to be a rather near neighbor of ours. Do not misunderstand me when I speak of more rapid motion and of rather near neighborhood. The real rate of 61 Cygni's rush through space is believed to be about 36 miles each second or more than 1000 millions of miles each year. All we can perceive of this quick motion is that in the course of 350 years, 61 Cygni travels over a space in the sky about as long as the breadth of the full moon. Little enough, yet far beyond that detected in the greater number of even the brightest stars. Then again, as to the near neighborhood of this star, 61 Cygni is near enough to have his distance measured, and that is saying a good deal. Alpha Centauri, the nearest star of which we know in the southern heavens, is more than 200,000 times as far distant as the Sun. But 61 Cygni, the nearest star of which we know in the northern heavens, is nearly twice as far, or some 40 billions of miles away. We call 61 Cygni a star, for so he appears to common observers. In reality, instead of being only one star, the speck of light which we call 61 Cygni consists of two stars. The two are separated by a gap about half as wide again as the wide gap between the Sun and Neptune. Yet, so great is their distance from us that to the naked eye, the two seem to be one. These two suns might together make a sun perhaps about one third as large as our sun. These two suns might together make a sun perhaps about one third as large as our sun. They differ in size, the quicker movements of one showing it to be the smaller, and it is by means of their known distance from one another and their known rate of motion that their size, or rather their weight, can be roughly calculated. Of course, neither of the two shows any actual measurable disk. So much and so little is with tolerable certainty known about this particular pair of suns. Next, let's turn to Alpha Centauri, named Alpha, the first letter of the Greek alphabet, because it is the brightest star in the constellation of the Centaur. The second brightest star in a constellation is generally called Beta, the third Gamma, the fourth Delta, and so on, just as if we were to name them A, B, C, D in order of brightness. The constellation Centaur lies in the southern heavens, close to the beautiful constellation called the Southern Cross, and is invisible in England. Of all the stars shining in the heavens around our earth, two only, Sirius and Canopus, show greater brilliancy than Alpha Centauri. As in the case of 61 Cygni, astronomers were led to attempt the measurement of Alpha Centauri's distance by noticing how much more distinct were his movements than the movements of other stars, though less rapid both to the eye and in reality than those of 61 Cygni. The distance of Alpha Centauri from us is more than 200,000 times the distance of the Sun, or about 20 millions of miles. In other words, light traveling at the rate of 186,300 miles each second takes 4 years to journey from Alpha Centauri to Earth. And this, so far as we yet know, is our Sun's nearest neighbor in the heavens outside his own family circle. Alpha Centauri, like 61 Cygni, is found to consist not of a single star but of a pair of stars. It is a two-sun system, whether or no surrounded by planets cannot be told. The two suns of the Alpha Centauri double star are separated by a distance about 22 times as great as the distance of the Earth from the Sun, yet to the naked eye they show as a single star. Here again one is much smaller than the other, and the smaller revolves round the larger in about 85 years. It is supposed that the two together might form a sun considerably larger and heavier than our sun. This belief is strengthened by the great brilliancy of Alpha Centauri. Our own sun, placed at that distance from us, would shine only about one third as brightly as he does. Turning now from the sun whose distance was first measured and from the nearest star with which we are acquainted, let's think about the most radiant star in the heavens, Sirius, the blazing dog star of the ancients, named by one astronomer the king of suns. First, as to the color of Sirius, he belongs to the order of white suns, and among all the white suns known to us, Sirius ranks as chief. There may be many at greater distances, far surpassing him in size and weight and brilliancy, but we can only speak so far as we know. One ancient writer spoke of Sirius as red in hue, others followed suit, but the original epithet was probably a copyist's mistake. It is at all events not to be depended on. Secondly, as to the distance of Sirius. Like a few other stars, Sirius lies not quite so far away as to be beyond reach of measurement. No baseline upon Earth would cause the slightest seeming change of position in him, but as our Earth journeys round the Sun, the line from one side of her orbit to the other is found wide enough. A baseline of 185 millions of miles does cause just a tiny seeming change. It is very little even with Alpha Centauri, and with Sirius it is much less. The displacement of Sirius is so slight that to measure his distance with exactness is impossible. Roughly calculated, Sirius lies at a distance of about 50 billions of miles. Our Sun, at the distance of Sirius, would shine merely as a star of the third magnitude. Light, which reaches us from the Sun in nearly 9 minutes and from Alpha Centauri in 4 years and one third, cannot reach us from Sirius in much less than 20 years. Thirdly, as to the size of Sirius. Here, of course, we are in difficulties. Radiantly as Sirius shines on a clear night, and dazzling as he looks through a powerful telescope, he shows no real disk or round surface capable of being measured. But although we cannot measure his size, we do know something of his weight and of his extraordinary brilliance. The brightness of Sirius is so much greater than the brightness of our Sun would be at that same distance that it certainly seems to point to the fact of Sirius being very much the larger sun of the two. The only reliable method by which a star's probable weight can be calculated is through the discovery of a companion to the star and a knowledge of their relative distances, their times of revolution, and the speed of either. For a long while, since Sirius was not known to possess a companion, this mode of computation could not be followed. Like other suns, Sirius has his proper motion, as it is called, an outward whirl through space of more than 1000 miles each minute, sometimes more, sometimes less. Mysterious irregularities in the pace of Sirius were noted as long ago as the year 1844, and by dint of careful thought, a decision was reached that some large disturbing orb must surely belong to Sirius and revolve round him. A body large enough and near enough to exercise a disturbing influence over the great sun, now hastening him on, now pulling him back, even as Jupiter and Saturn by turns hurry and delay one another. There the matter rested during fully 18 years. Then one night, the dim gleam of this companion was actually seen, and having been once discovered, it was perceived again and again. So the truth of the surmise reached nearly 20 years earlier through simple exercise of reasoning power was proved beyond question. Although this faintly shining second star is so near to Sirius as greatly to affect the movements of the latter, disturbing his regularity of speed to an extent which could be noted 40 billions of miles away. Yet, the distance between Sirius and his companion is somewhere about 37 times as great as our Earth's distance from the Sun. The dim companion appears to be in weight about equal to our Sun, while the bright star, Sirius, is not much more than twice as heavy. Weight, however, tells little as to size. The blazing radiance of Sirius is extraordinary compared with the dimness of his companion sun. Probably the latter is far cooler and consequently far denser and smaller in make, while the dazzling Sirius has doubtless a photosphere of incandescent gases and glowing molten clouds like to that of our sun, but greatly exceeding it either in size or in actual brilliance or probably in both. Fortunately, as to the motions of Sirius, already touched upon, it was long possible only to observe the movements of a star when he journeyed sideways across the sky. A star coming directly towards us or passing straight away from us would always appear to be at rest. Now, however, by means of the spectroscope, it has become possible to perceive and measure the end-on motions of stars to and from our solar system as well as their sideway journeyings. The sideway motion of Sirius had been discovered before, but it now appears that he does not move exactly sideways. He rushes away in a slanting direction at the rate of over 1000 millions of miles each year. Think how many millions of miles he must now be farther off from us than in the years of the ancient. Yet he shines on with undimmed radiance, still the most brilliant star in our sky. So small a matter are all those millions compared with the sum of his vast distance from Earth. It is an interesting fact that while Sirius is moving away from us, we are also moving away from him. Our first station ahead, which seems to lie in or near the constellation of Hercules, stands just in the opposite direction from the goal of Sirius. Fifthly, had Sirius a family or a system of worlds like our Sun? He may have or he may not. One companion he does possess, in the shape of a companion sun, greatly inferior to himself in luster. Whether those two suns possess a family of revolving worlds, we have no power to say. If one asks why not, no reason to the contrary can be given. But to say that a thing may be is not to say that it is. Any star in the heavens may have such a family, and any star may pursue his lonely path without an attendant near. When we do not and cannot know, it is worse than useless to be positive. Still, the discovery after long ages of this dim huge companion to Sirius, and the knowledge that a very slight further increase of dimness, or decrease rather, of shining would have made that companion absolutely undiscoverable by us, is full of significance. Even a faint star at that distance can barely be detected, and a planet shining by borrowed light could not possibly become visible. Such bodies may exist in countless billions throughout space, where we see only the glimmer of a more radiant sun dotting here and there the vast expanse. The mere possibilities thus opened out to imagination are almost appalling. Lastly, what is Sirius made of? Here again the spectroscope comes to our aid. Before the discovery of spectrum analysis and its application to astronomy, astronomers can scarcely be said to have known with certainty that stars were suns, and of the composition of those stars, nay, even of our own sun, they were in ignorance. Now we have learned much. Now the spectroscope, by breaking up and analyzing the slender ray of light which travels earthward from each star, has shown us something of the true nature of those far off lamps of heaven. Now we know that most of the stars, not all of them, are like our sun, great radiating machines for the giving forth of light and heat and power. Like our sun, each is surrounded by a brilliant photosphere formed in a fairy atmosphere of heated and glowing gases. In the white suns, of which Sirius is king and chief, while sodium, magnesium, and other metals do more or less exist, the principal component of this dazzling envelope is found to be incandescent hydrogen. Our sun belongs not to the first or Sirian class of white suns, but to the second or solar type of golden suns. In them, though hydrogen is abundant, it is not so absolutely prominent. End of section 23.